Hello, my name is Steve Turner. This presentation will discuss matrices and determinants as learned in Intermediate Algebra. There are a couple of terms that will be used throughout this presentation. A matrix is an ordered array of numbers. Elements are the numbers within the matrix. And a determinant is a function which as an input accepts n times n matrix, and output is a real or complex number. Here are some examples of matrices. By the way, a matrices is plural for matrix. A 2x3 matrix is or has 2 rows and 3 columns. A 2x2 matrix has 2 rows and 2 columns. It's also called a square matrix. A 3x3 matrix has 3 rows and 3 columns. Any matrix that has the same number of rows and columns can be considered a square matrix. Associated with every square matrix is a real number called the determinant of the matrix. This is symbolized by the entries of the matrix or the elements of the matrix placed between two vertical lines as shown here. This is an example of the rule used to evaluate a 2x2 determinant. We will multiply A and D and then subtract from that B times C. As shown in the example, we would multiply 6 with the negative 5, and then we would subtract 3 times 4. And 6 times negative 5 is negative 30. 3 times 4 is 12. So we'll have negative 30 minus a 12 equals a negative 42. So how do we evaluate 3x3 determinants? We evaluate 3x3 determinants by multiplying each element of the first column, A1, A2, A3, by its minor. This is called expansion of the determinant by minors. In the next few slides, you will see a visualization of how we obtained the 3 terms that are identified here. One thing to be aware of is the signs between each term. The second term is subtracted from the first. The third term is added to the second. We start evaluating the 3x3 determinant using expansion by minors at the first column. Here we will take A1 as the multiplier. We then eliminate the first column and the first row. Notice the remaining elements are viewed as a 2x2 determinant, and we can follow the rules as previously discussed. Therefore, our first term becomes A1 times B2C3 minus B3C2. We can now move to our second multiplier, A2. We eliminate the first column and second row. The remaining elements can still be viewed as a 2x2 determinant, and we can continue with the rules for evaluating a 2x2 determinant. This gives us our second term. And now we move to our third multiplier, which is a 3. Again, we eliminate the first column, and now we eliminate the third row, which leaves the remaining 2 by 2 determinant. And now we have our third term as shown here. We have now taken our 3 by 3 determinant and rearranged it in a form which allows us to evaluate the determinant. Let's try this using real numbers in this example. As you can see here, we have taken the 3 by 3 determinant, and using the previously described method, we are able to evaluate the determinant. The brackets used here are to reduce confusion within the equation. Let's quickly review each term. Here is our first term. And now we have our second term, the multiplier being the -3, and the 2 by 2 minor within the brackets. And finally, our third term, the number 2 being our multiplier, and again, the minors within the brackets. We have now rearranged the 3 by 3 determinant into an equation that we can work. We do the work within the brackets, and it's just a matter of simple addition and subtraction. As a result, we see that this 3 by 3 determinant is equal to 59. As I thought about these rules of determinants and how the rules apply to Christians, I think of Romans chapter 8, verse 1, which says, "There's therefore now no condemnation for those who are in Christ Jesus." In other words, if we as Christians are in Christ or associated with Christ, we are saved. While there is one real number that is associated with every square matrix, every individual has a personal and distinct relationship or association with God. It is this personal association with God which is required for salvation.